Hello everyone, welcome to another lecture. In this lecture, we'll provide a brief explanation of value types versus reference types. You should know that we'll cover this topic in detail during the intermediate course. Alright, variable types are divided into two main categories, value types and reference types. To have a solid understanding, it's crucial to grasp the difference between these two categories and how they interact with memory. So, let's take a closer look at how data is stored in memory by variables, starting with value types. A data type is considered a value type when it holds the value of the variable directly in its own memory space. To understand this concept better, let's explore an example. Suppose we have a variable named number1 with a value of 10. How does this variable store in memory? When we create a value type variable like the number1 variable, a single space in memory with a specific location is allocated to store the actual value of the variable. In this scenario, when we declare the number1 variable with a value of 10, a unique memory location is allocated to store its value, and the value of 10 is directly stored in that dedicated memory location. It's important to note that floating point numbers, integral numbers, chart type objects, etc. are all examples of value types that store their actual values directly in memory. Alright. Reference types are data types that store references to memory locations where the actual data is stored, rather than storing the actual data directly in memory. To understand this concept better, let's explore an example using a variable called player, which represents an instance of the player class. Okay, what is the memory allocation process for this instance variable? When we create a reference type variable such as the player variable, two memory locations are allocated, one for storing the actual data and another for holding the reference or memory location of that data. In this scenario, when the player1 variable is initialized, two memory locations are allocated. The first one is for holding the actual data with a specific memory location, and the second one is for the player1 variable which holds the reference or memory location of the actual data. Now, as you can see, the player1 variable refers to the actual data by this memory location. It's important to note that all instances that are created by a class as well as string objects are reference types in C#. In summary, value types and reference types have different memory allocation behaviors. Value types store data directly within their own allocated memory space. On the other hand, reference types contain a memory location that references the specific memory location where the actual data is stored. Alright, these two types also have different assignment behaviors, which are important to understand for working with variables in C#. So, let's begin with value types assignment behavior. When we assign a value type variable to another variable, the value is directly copied from one variable to another. Let's illustrate this assignment behavior with an example. As you can see, we have a variable named number1 with a value of 10. If we declare another int variable named number2 and assign the value of the number1 to it, the value of number1 will be copied to the number2 variable and a separate memory location will be allocated to the number2 with a value of 10. We now have two separate memory locations for the number1 and number2 variables, and each of them holds the value of 10 independently of the other. Now, if we change the value of number 2 to 5, since both variables have their own separate memory locations and are independent of each other, the change in number 2 will not have any effect on the value of number 1. As you can see, the value of number 1 still remains 10, and only the value of number 2 has been changed. According to what we said, let's see this assignment behavior in VS Code. After running this piece of code, we can observe that the value of the number 2 variable is changed to 5. However, the value of the number 1 variable remains 10. This demonstrates that changes to one value type variable do not affect other value type variables, as each variable has its own independent memory location to store its data. Alright, now let's explore the assignment behavior of reference type variables. Unlike value types, when we assign a reference type variable to another, no actual data copying happens during this assignment. Instead, a new reference or pointer is created that refers to where the actual data is stored in memory. So, both variables refer to the same data in memory. Okay, let's illustrate this assignment behavior with an example. As you can see, we have a variable named player1 that holds the reference of the actual player data in memory. Now, if we declare another reference type variable named player2 and assign the player1 variable to it, both variables will refer the same data in memory. This means that if we change any of these variables, it will be reflected in the other variable since they both reference the same data in memory. For example, if we change the value of player 2's jersey number to 18, it will affect the value of player 1's jersey number because both variables refer to the same data in memory. So, the jersey number of both variables will be 18. As you can see, both of these variables hold the same memory location that refers to the actual data. This means that any change in this data will affect all variables that refer to it. For example, when we changed the jersey number to 18, all variables, including player1, were affected. This allows both variables to access and work with the same data without duplicating it. According to what we said, let's see this assignment behavior in VS Code. After running this piece of code, we can observe that while we haven't changed the player 1's jersey number at all, the jersey number value of player 1 and player 2 variables is changed to 18. Alright, it's worth noting that understanding the differences between value types and reference types is crucial for designing and writing efficient and effective code in C#. So, to gain a better understanding of these concepts, we recommend watching this lecture multiple times. If it's difficult for you to understand these concepts at first, don't worry, it's completely normal. We'll talk more about these concepts during the intermediate course. Alright, one thing you should know is that string objects are all reference type, but when we change their value, they behave like value type objects. That's because string objects are immutable, meaning their values cannot be changed once they are created. This concept of immutability is the subject of our next lecture. See you there.